All right, guys, welcome back. So let's talk a little bit, continuing on from our lecture from the other day. These are a few reminders, all right? So we got the sun, and our sun is the ultimate source of all energy on Earth, right? So we're going to take that light energy, turn it into chemical energy, and producers are going to be the ones that are going to do that, all right? So what's going to eat the producers? Valid question. All right, it is our first order, our primary consumers. These guys are herbivores. Once again, they eat the plants that turn that sunlight energy into chemical energy. All right. After that, we're going to go to our second order, or secondary consumers. These can be carnivores or omnivores. Now, once again, our carnivores are meat eaters, and omnivores are a little bit of everything. Okay, what do I mean by everything? I mean, they can eat vegetation, they can eat berries, all right, nuts, all right, but they also eat meat as well. And third order, our tertiary consumers, once again, are omnivores or carnivores as well. All right, so new stuff. We got a food chain. Now, in a food chain, the energy transfers from the sun in a linear fashion, so like a straight line. So we got our sun here. It's going to go to our producers. It's going to go to our first order. Then we got our second order. All right, we got our third order. Now we can have fourth, fifth, sixth order. It all depends. But once again, I am not going to expect you in this class to remember anything above a third order or a tertiary consumer. So a few things about a food chain. Something you need to note is the arrows point in the flow of the energy. So the energy flows from the sun to the producers. The energy from the producers flows to the cricket. The energy from the cricket flows to the frog, and so forth and so on. Okay? So it's a linear fashion. It's not all mixed up, jumbled up. We're going to get there in a second. All right, but this is just a straight line. So they show, and they can show, the amount of available energy at each level. So, like, for example, here we have 1,000 units, all right? And here we have 100 units, 10 units, and 1 unit. And we're going to talk a little bit more about this math in a second, okay? This is a great example of an energy pyramid. We have energy that starts on the bottom, all right, and it flows up, okay? One thing I do want to draw your attention to is you'll notice how many plants it takes just for the grasshoppers. You notice how many grasshopper it takes just for the frogs. And honestly, we should probably have a couple more frogs here too for this top order consumer, because as we go up each level, all right, some of that energy is lost. All right. So once again, we got lichen to slug, slug to frog, frog to snake. All right. You got one down here where we only have first order, all right, and second order, and that's fine. Okay. Usually most of the time on a test or a quiz or something, I'm going to ask you to pick out 3, all right? But it doesn't really matter. It can be 100 things long. It could be 3 things long. Anywhere in between is perfectly fine. All right, another way we can show this transfer of energy in the system is energy pyramids. Now we're going to talk about an energy pyramid. We're going to talk about a biomass pyramid, and we are also going to talk about a pyramid of numbers. All right, so let's talk about the energy pyramid first. It shows the amount of available energy at each level, and it decreases as we go up. All right, so it takes a large number of producers. I'm going to use these numbers for each because it's nice and easy, okay? So in the energy pyramid, whatever energy unit we're talking about, usually for us as humans, we usually refer to kilocalories, all right? And if you look at the packet of food that you have, like it says, 100 calories. It's kilocalories. They just leave off the K, all right? But at each level you see here, we go up, we're missing some energy, right? Something's going on. Well, a lot of this energy that is missing, so to speak, is lost in the form of just these organisms carrying out like normal life function. So we got 1,000 available units of energy here, only 100 available energy for the next unit. Why? because these little bunnies, they need energy to do bunny things, okay? We're going to lose 90% of that energy at each level, okay? So once again, boom. All right. Usually in the textbooks, you see it in the form of heat, but it's really all about like body processes, things that the animals do on a regular basis, right? They need to live, so they have to use some of that energy. So only a little bit gets passed, all right, from level to level to level. So what we're talking about here is the 90-10 rule, okay? In the 90-10 rule, 90% of the energy is lost, only 10% goes to the next level, okay? And that kind of bleeds right into what we'll talk about next here, which is the biomass pyramid, okay? In our biomass pyramid, we're going to keep all these same numbers, okay? But you'll notice that in this, all right, as we do this, all right, these numbers go down. So it says like 1,000 blades of grass, for example, to keep this alive, okay? To keep these bunnies alive. It takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bunnies to keep 3 snakes alive. It takes 3 snakes to keep 1 hawk eagle alive. So at each level we go up, okay, it's going to require there to be more organisms underneath than on top of it. All right. So at the very top, you're going to have very few organisms, a little bit more, a little bit more, a little bit more. Okay. And that can be true for the same thing of a biomass pyramid. We're just going to change the unit that we use here as opposed to, there we go. All right. As opposed to kilocalories or something like that, we're going to have like grams. I'll just keep it nice and easy with grams. Okay. And these are fictitious numbers, and this hawk weighs more than 1 gram, trust me. Okay. But once again, as we go up each level, there's less biomass available at each time. So we need a lot at the bottom of the pyramid. And as we go up each time, we're going to need a little bit less, or there's going to be a little less energy available, a little less biomass available, a little less organisms available. Doesn't really matter how you look at it. We're still going to lose a lot as we go up each level, and primarily that is used for just life processes. And like I said, it takes a large number to support a smaller number, secondary, smaller number of tertiary, smaller number of quaternary. You can keep going up and up and up. All right, so now let's talk a little bit about food webs. So obviously, if you think back to that first picture, that's not all the feeding relationships or options there are in there. So in an ecosystem, we have what's called a food web. It's a great term because it, like just like a spider web, has a bunch of different connections. So do these. So let's take a look. So I'm just going to pick a few, and we can, kind of go through them. So we got our producers, we got our first order bunny, all right, we got a second order fox. Okay, we can also have our producers. Once again, always starts with our producers. Go to herbivore, insect, predaceous insect. So we got first, second, we got our toad at third. Okay, if we keep going on this. Now we got our snake at fourth. Okay, another one. So we could go back to here. Let's do insect, spider, bird, hawk. All right. Plant, bird, hawk. Mice, hawk, or mice, snake. Okay, these are all the feeding relationships that we could possibly have in a food web. All right. So something that I would be looking for here is you to draw a couple of different food chains inside of the food web, and then label, are they a first order? Are they a second order? Are they a third order? Are they a herbivore? Are they an omnivore? All right. Some terms on here that I'm not going to expect you to remember is insectivore. This is just something that eats insects. Predaceous means it's going to prey on something. All right. Those terms I'm not going to worry too much about. If you ever take AP Environmental Science, we'll talk about more of those later. Those different categories. The only thing not on this food web, and a lot of times you don't see them, are, I'm just going to draw up here. All right, here's my poorly drawn mushroom. Okay, we have decomposers. Okay, decomposers are many times not in our food chains or food webs, but they are always there. Okay, after organisms die, get eaten, whatever the case may be, there's going to be biomass left over. So you're going to need decomposers to break that down. You can also have a little bacteria. All right, that's another good decomposer. Now the difference between this, we're going to finish on this one today. The difference between a decomposer and a scavenger is a decomposer is going to break things down at a chemical level. All right. A scavenger, which they eat dead things too. All right. I get could be some confusion there. All right. But they're going to eat, like, they're going to physically break it down. So like the fox lives a nice long life and keels over at some point. Okay. So the vultures and the other animals are going to come down and eat it and, take its flesh off the bone. It is what it is, Mother Nature. All right. But all that other stuff that's left over, all right, is going to go to the decomposers. All right, guys. So come on in with questions. All right. I know there'll be some. Perfectly fine. And we're going to do some of these in class. We're going to walk through some food webs. We're going to answer some questions about food webs, food chains, and how it all interconnects. All right. See you in class.